So we're going to move from the arithmetic to the geometric sequence. As the slide states, geometric sequences differ from arithmetic in that they have a common ratio from term to term, or multiple, depending on how you want to look at it. If I take any term and the term before it, such as 54 over 18, I get that ratio, which is 3. Then 162 over 54 better be the same thing, and it is, so r is equal to 3. Looking at this next one, we can see that going from term to term, we have multiples of 2 each time, and r is 2 here. Now, just like in the arithmetic, we'll go ahead and develop how we would get an explicit formula for an for a geometric, sequence. We know that 10 is 5 times 2, and we know 20 is 5 times 2 squared, 40, 5 times 2 cubed, 80, 5 times 2 to the 4th. And then we look at common things happening. We have 5, we have 2, and then we look at the relationship between the subscript and the power. And in each case, that subscript is 1 more than the power, or the power is 1 less than the subscript. 5 was the first term. 2 happened to be the ratio to the n minus 1, gives us whatever term we're looking for. So the general equation for that explicit geometric sequence, again, this is explicit, which allows us to basically find any term given the n value, is a sub n is equal to a sub 1 r to the n minus 1, where all these values are the same as they were in the arithmetics. Little plug and chug now. I'm going to use the same trick I used in the arithmetic process. I'm going to let the third term equal the first term, which in this case is 96, and then let the 20th term equal the 18th term, because that's 2 less in terms, and solve for the 18th term. So in this case, I have the 18th term is equal to the first term times the ratio, which is 4 in this case, to the 18 minus 1. The 18th term, which is really going to be the 20th term, is equal to 96 times 4 to the 17th. Pretty astronomical, but you can pop that into a calculator and get it if that's what they really want. Now we'll write the explicit formula for the nth term. Sometimes they'll say write the explicit formula. Sometimes they'll say find the nth term. And you don't know what n is, so they're basically saying, without saying, find the explicit formula. So all we have to do is say, well, my nth term is going to equal my first term. We can just eyeball this and know our ratio is a half, 80 over 160 for those that can't eyeball. And then 40 over 80, just for fun. And then that's going to be to the n minus 1 power. It's just a vocabulary thing that guys get confused at. What are you looking for when they ask for the nth term? So let's move on to a series, which is the sum of all the terms in a sequence. Now, Gauss played a big role in this as well, except he didn't go about switching the order of the terms and then adding them up and getting some new pattern. He had to go a little deeper. And in this case, he multiplied the entire series by the ratio r. Multiplying the first term by that ratio gets me the second term. Multiplying the second term by that ratio gets me the third term. And this went on for days till we got to that nth term. Remember, this is a sub n. All right. But when we multiply this r by this term here, remember that's r to the first, and we will add the powers of r in order to get that multiplication. So our last term in this sum is going to be the first term times r to the n. Gauss then said, well, I need an equation for this. So what he did is he looked at this thing and said, hey, if I subtract this, look at what happens. I've got the sum minus the ratio times the sum equals that first term. All these middle terms go away since they match and we're subtracting. And then we're subtracting this last term off that's hanging by itself. We then factor in both cases and solve for the sum just by dividing that 1 minus r term. And we end up with a formula that describes a general equation for a geometric sum. Written a little cleaner, looks like this, where we have our sums equal to the first term times the ratio to the nth power. This is great when you know how many terms there are, the first term and the ratio. Not so good when you're given that nth term. So in that case, I would use this formula, which allows you to do the same calculation, having the first term, the nth term, and the ratio, but you don't need to know the number of terms. And we can do that because the nth term is equal to a1 r to the n minus 1. So let's practice doing a couple of problems using one of those two. Now this gives us n. We have the first term in r, so we're going to use that first formula. The sum of the 12 terms is equal to that first term times 1 minus the ratio to the n over 1 minus that ratio. Simplifying, get the same numerator. And we notice that the denominator goes to a 4, so this reduces, leaving you with 1 minus negative 3 to the 12th, which is a sum. And this goes to 1 minus, that's basically going to be what? 3 to the 12th, because negative 3 raised to the 12th power is a positive term. And that's going to get us roughly negative 531,440. And that's that sum. Knowing the simplest formula to use is really the key here. So if I look at this problem, notice I'm given the nth term, first term, ratio, giveaway that this should be the second equation because I have a1, 48, minus an, 3, r, to the 1 over the r value. I think I said 1 over the r value, 1 minus the r value. So in this case, I have 48 minus 3 halves over 1 half. And that's a simple plug and chug on your calculator. And we end up with, I believe it's 93. So this problem is just a little bit different. They tell us the sum, but they actually give us n, and they give us the ratio, and we want to find the fourth term. I'm going to find the first term first and then work our way back to get the fourth term. So to do this problem, I think I'll use 315, that's the sum, is equal to that first term, which I don't know, times 1 minus the ratio, which is a half. Since they give us n, I'll use that over 1 minus that ratio. So notice I've got everything except for the first term. I should be able to solve this. So I have a half on the bottom. I'll multiply that to the other side. So this is 315 over 2 is equal to the first term times 1 minus, that's 1 over 64. So this is 63 over 64 times that first term is equal to 315 over 2. And the first term ends up equaling, I think that's 160. All right. Therefore, if that first term's 160, not real hard to find the fourth term, I know I can just say the fourth term is equal to the first term times the ratio, which we know is a half, to the 4 minus 1. So this is 160 times 1 over 8, which is 20 in this case. Little sigma notation now. Again, we're going to use one of these. I want to make sure this is a geometric sequence to begin with. Notice from this equation, I can get the first term and the last term. I can probably also get the ratio in this, so I'm not sure that one is easier than the other. But if I plug in a 1, I basically have negative 4/3. If I plug in a 2, I have negative 4/9. If I have a 3, I have negative 4/27. So it's pretty easy to see that when I divide, my ratio is a third. I'll just go ahead and say S sub 10 is equal to my first term times 1 minus my ratio to the 10th power over 1 minus my ratio. And again, this is pretty much a calculator problem. So let's go ahead and calculate that. Doesn't work out super clean. We end up with negative 1.99996-ish. Right around there. Second problem has our little trick in it. We know that in this case, n is not 12 because we're starting at 5. So we know that 12 minus 5 plus 1 gives us our n value. So we have n equaling 8. So now again, I'm going to take and pop a 5 in, get my first value. So this is 1/2 to the 6th, which is 1 over 64. And then this is just going to keep going all the way up, right? Our ratio is going to be a half because that's what we're doing. We're increasing that power by 1 every time. All right. And we have 1 over 128, 1 over 256. We could do this by hand, but we're going to do it in a formula real quick. And we'll just plug this in. Again, it really doesn't matter. I think we can plug into the S sub 8 is equal to A1, which is 1 over 64 times 1 minus the ratio, which is a half, to the n. We said n was 8 over 1 minus 1/2. Again, we turn that into a calculator problem. And this is small enough or big enough, however you want to look at it, to write an exact fraction of 255 over 8192. All right. And that's all we've got to show you for today. Make sure you do your My Math Lab, and we'll see you tomorrow.